Okay, so here we are with number 13. It says, the table shows the amount of time 4 students practice the trumpet in one day. So you have all of these kids practicing the trumpet, Cole, Gus, Ron, and Jacob. They all practiced for at least 1 hour and then a little bit more. Use the list above to put the names of the students in order from the greatest amount of time practiced to the least amount of time practiced. Now on your test, the same information is on there, but it's not the exact same question, okay? So I need you to be careful on your test and make sure that you read the question. Okay, it's not exactly the same. It's the same information, but the question is different. Okay, so we have 1 2/3, 1 1/2, 1 1/4, and 1 7/12. Well, I know that 2/3 is not going to, it's not even, right? It won't stop. It's a decimal that keeps going. And 7/12. I mean, 7/12 will go on for, let me see, ever. So changing them to a decimal is really not the best idea. So my recommendation is to find a common denominator, okay? So I want you to put up here, common denominator. That's your clue on this one, okay? So I have 3, 2, 4, and 12. Well, 3, no, can't go to 2. So let's just do 12, okay? Just find the common denominator, 12. So the 1 will stay the same. This will be 1 and 7/12. This will be 1 and 12. This will be 1 and 12. And this will be 1 and 12, okay? Okay, the common denominator here is 12. So what did I do to this 3 to get 12? Times what? 4. Okay, what's 4 times 2? 8. What did I do to this 2 to get 12? Times 6. So that'll be 6. And this would be times 3. So now I have 1 and 7/12, 1 and 3/12, 1 and 6/12, and 1 and 8/12. Okay, so when I have a common denominator, it's easy to see which one is the biggest because all of the pieces are the same. So whichever one has most of the pieces filled in, that's what will be the greatest amount of time or the least amount of time. So this says greatest amount of time. So I'm looking for the one that has, they all have at least 1 hour, but I'm looking for the one that has the closest to having another whole. Well, I have 8, 6, 3, and 7. Which one of those is the biggest? The 8. So I have Cole at 1 and 2/3. You always have to revert back to the original. And then I have Jacob at 1 and 7. Oh, not 7/12. Oh yeah, 1 and 7/12. That one stays the same. Okay. And then I have Gus at 1 and 1/2. And then last I have Ryan at 1 and 1/4. Okay, so the best bet on this was to find a common denominator. Easy, you've been finding a common denominator forever. Find a common denominator, and this one said the greatest amount of time practice to the least amount of time practice. So this was big to little. Watch your question tomorrow though, or whenever you take the test, because I do not think it's the same. Okay? Number 14, Rebecca will correctly label the numbers 38 and 4/10, 38 and a half, 38 and 900, and 38 and 3/5 on a number line. Okay, so you have a number line here. On your test, I'm pretty sure the number line is broken up into tenths. So let's just go ahead and do that. So if I wanted to break something up into 10, that means I would need 9 equal parts. So I would just kind of start with the half. And remember, it's never going to be perfect. So you would have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10. And then that would be 10/10. So now this is broken up into what? Tenths. We are going from 38 to 39. Remember, there's a million infinity numbers in between two whole numbers. Okay? I've just broken this up into into tenths. Now let's start with the easy one. Okay, 38 and a half. Well, there's 1, 2, 3, 4, 5. So this would be 38 and a half. That one's easy enough. 38 and 4/10. Well, 4/10 is less than 5/10, so it would be right here. So 38 and 4/10. 1/10, 2/10, 3/10, 4/10. Okay. Then I have 38 and 9/100. 38 and 9/100 doesn't even get me to a 10. So it's going to be way over here. It's not even going to be on one of our little marks. It's about right here. Okay. And then I have 38 and 3/5. Well, 3/5 as a decimal would be what? Well, let's see. Can you get that 5 to something that you know? Sure, you can get that to a 10. What do I do to this 5 to get 10? Times 2. So that would be times 2. So this is 38 and 6/10, which would be where? Right here. 38 and 3/5, or 38 and 6/10. So which one of these numbers is closest to 39? Well, 38 and 3/5. Pretty easy, huh? Okay, number 15. The shaded model represents 100%. So this entire thing represents 100%. The whole thing is 100%. That's one whole. This represents one whole. This says draw a model that represents 33 1/3%. Okay, this isn't 33 wholes. This isn't 33 1/3 of another whole. This isn't even 3 wholes. This is not even one whole. This is 33 1/3%, which I know because my teacher told me to memorize this, that 33 1/3% is equivalent to 1/3 or 0.3 repeating. Okay, so if I wanted to draw a model that represented 1/3 of this shaded model, I could just take another model, exact same, that's the same size, that would be like 100%, and then color in 1/3 of it. Do not, I repeat, do not mark that 33 1/3% is 3 wholes and a part of another one. No, this is 33 1/3% is equivalent to 1/3. What would be 1/3 this entire thing? This one is a freebie. Do not miss. It's a baby easy one. Okay? Meteorologist Zane reported that a town received 0.85 or 85/100 inches of rain yesterday. Write a fraction that is equivalent to this amount of rain and its equivalent decimal. Well, I think this should really say percent. Put percent right here. Miss Gentry messed up. Okay, so 85/100, write a fraction that is equivalent to that. So you have 85/100. Write it the way you say it. Now, can 85/100 be simplified? Yes. By what? 5. Okay. I'll go with that. How many times will 5 go into 85? Well, if you don't know, you would have to come over here and do 85 divided by 5. It'll go in there once. Bring that down. It'll go in there what? 5 will go into 35 how many times? 7. So that would be 17 over, what's 100 divided by 5? What times 5 will give you 100? Good. 20. So this is an equivalent fraction. This is an equivalent fraction, but it also wants the percent. Well, 85/100 is 0.85. How do you go from a fraction to a decimal to a percent? Move the decimal 2 places to the right and you would get 85%. Also a freebie. Also a baby freebie. Do not miss this. This is something we've been doing all year. Put these numbers in the correct square. We will draw the Venn as a class. Okay, so on your test, you are going to be given, I'm going to put you, oh, we're not even on the right one. Okay, on your test, you're going to be given some numbers, and you're going to have to put them in the correct place on the Venn diagram. Our Venn diagram in our comp book is a circle, but this time on the test, it's a square. So that's perfectly fine. We can do a square just as easily as we can do a circle, so it's not a big deal. So we're going to draw this together. Okay, so when we're drawing this, I would just draw one big square. Okay, and in this square, I would put rational numbers. Okay, and then I'm going to draw another pretty big square. And I'm going to put integers. And then I'm going to draw another square. These aren't squares, these are rectangles. Whatever, you know what I mean. And I'm going to put whole numbers. Okay, so remember, your Venn can work outwards. It can work, if it's a whole number, it's also an integer. If it's an integer, it's also a rational number. So it can start here and work out, but it doesn't always work going the other way. Okay, so let's just do the ones that we know that is super, super easy. What is a whole number? It's a positive whole number. Which one of those is a positive whole number? 17. Now, is 17 also an integer? Yes. Is 17 also a rational number? Yes. But the first one that it falls into is a whole number. Okay? Then I have an integer. An integer is a positive and negative whole number. If you don't know that, you can write that out here to the side. Integers, positive and negative whole number. Okay, do I have a positive or negative whole number? Well, I had 17, but it originally fell into the whole numbers. What about negative 5? Yep. And then I have rational numbers, which rational numbers are any numbers that can be written as a fraction. Well, 4 3/10 could be written like this, right? So that's a rational. Negative 1 2/10, negative 1 2/10 could be written like this. And then I have 0.03½. Now, could 3½ have been written like this? Absolutely. Guys, don't miss this. It is all over your notes. There's zero reason to miss this question. Okay? Absolutely do not miss it. Okay, I'm going to stop the video right now, and I will start another one with question 18.